In math, we deal with real numbers and not real, which we call imaginary numbers. Both of those fall under the umbrella of complex numbers, but you don't need to worry about that for now. We are just going to live inside real numbers. Real numbers have a decimal expansion. We can write it in some sort of decimal. Maybe the decimal goes on forever, maybe it repeats, maybe it doesn't, but it has a decimal expansion. These are all real numbers: whole numbers, negative numbers, a decimal that ends, a decimal that repeats, a decimal that has a long repeat, even pi, which is an irrational number, and the decimal never repeats and never ends. It's still a real number. The imaginary numbers we are familiar with are mostly like square roots of negatives. So, like the square root of negative 36 is a not real number, that's imaginary. Inside real numbers, we also have a subcategory of rational numbers. Rational numbers can always be written as a fraction, a over b, where those are both whole numbers. Its decimal expansion is either finite, it stops, like 2.45, that's a finite decimal expansion, or it's a repeating decimal expansion, like 2.45454545. All of these are real numbers. So, looking at which of these are rational, this guy's rational. This terminating decimal is rational. This repeating decimal is rational. Pi and the square root of 35 both have decimal expansions, but they do not repeat and they never end. So those are irrational numbers. So we are going to work inside real numbers. Remember, our imaginary numbers were like square root of negative 100. We've seen already rational numbers represented as a fraction in some way, and irrational numbers, square roots, pi, in general, decimals that don't repeat and that go on forever. Inside rational numbers, there are also these subcategories. We're not worrying about them right now. Real numbers have these properties we're going to go over together: the associative property, commutative property, and distributive property. They also have identities and inverses that are different depending on the operation we're using. So the associative property, when we're talking about addition, looks like this. I can put in groups, and if everything is addition, it doesn't matter where I put in that group, those parentheses, that grouping. It doesn't matter where I put it in. If everything's addition, moving that grouping isn't going to change the value of my problem. So 3 plus 4 plus 5 is going to be the same as if I first added the 3 plus 4 and then added 5, right? This turns into 3 plus 9, and this turns into 7 plus 5, but both of those are still 12. As long as everything's addition, it doesn't matter the order I go in. Similarly, in multiplication, exact same thing. If everything is multiplying, then I can put groupings anywhere, and my answer is still going to come out the same. So if I had 2 times 3 times 4, if I just had no parentheses in there, I would just go left to right. 2 times 3 is 6, 6 times 4 is 24. But if I put in a grouping here, I have 2 times 12, still 24. If I put in the grouping here, 6 times 4, still 24. That's the associative property. Where you put in a group, like those parentheses, doesn't matter if you have the same operation throughout. The commutative property is telling you that order doesn't matter. Again, if you have the same operation throughout. So commutative property of addition is basically saying 2 plus 3 is the same as 3 plus 2. Of course it is. 10 plus 5 is the same as 5 plus 10. This is also true in multiplication. 2 times 3 is the same as 3 times 2. The order doesn't matter in a commutative property. So this is like 2 times 7 is the same as 7 times 2. The order you write them down in doesn't matter for the solution. In addition, we have an identity, something that does nothing. And that identity is 0. If we add 0 to any number, it's not going to change the number, right? 10 plus 0 is still 10. 12 million plus 0 is still 12 million. So then the inverse is negative of that number, right? So the additive inverse of 4 is negative 4, because 4 and negative 4, we're going to add together to give us our identity, which is 0. What would the inverse of negative 10 be? The inverse is going to be positive 10, because we are taking the negative of negative 10, and that negative makes it back to our positive 10, right? Those guys are inverses because they cancel each other out. We get back to nothing, the addition version of nothing, which is 0. When we get into multiplication, we have a different identity, because if we multiply by 0, it does change the answer, right? 10 times 0 is 0. That's not 10 anymore. So the identity in multiplying is 1. When you multiply by 1, it does not change your answer. The inverse in multiplication is the reciprocal, or refliprical, we used to call it in middle school. And it is the number that when you multiply it with your original number, they're going to cancel to leave us with the multiplication version of nothing, which is 1. So the inverse of 2 is 1 over 2, because when we multiply 2 and 1/2, we get 2 over 2, which is just 1. The inverse of negative 5, remember that every whole number just has a 1 underneath it. The inverse of negative 5 is 1 over negative 5. When we multiply those together, they're going to cancel to be 1. The inverse of 2/3 is going to be flipped 3/2. Now we have 6 over 6, which is 1, our identity. So the inverse is always going to be the reciprocal, which is essentially that number flipped. Now you need to be careful with 0. We know that in addition, and therefore also in subtraction, 0 is the identity. It's not going to do anything. We know that any number multiplied by 0 is going to be 0. And we have previously seen that if you take 0 and divide it by a number, you get 0. That's the question of like, how many 5s are there in 0, right? 0 divided by 5 is saying, how many 5s are there in 0? There are 0, because there are no 5s in it, right? We have nothing. But when you flip it the other way, you had 5 divided by 0. This is undefined, because how can you decide how many nothings there are in something? So whenever we're dividing by 0, we should hear alarm bells going off in our head. That is always going to be an undefined answer, because we cannot divide a non-zero number by 0. 0 divided by 0 is its own little thing. Last, we have the distributive property. In this distributive property, we're combining, maybe adding and subtracting with multiplying or dividing. So in the distributive property, when you have a number being multiplied by a group, you can distribute that multiplied number out to everything in the group. You sometimes will see us draw rainbows like this. So we say A times the group B plus C is the same as A times B plus A times C. You want to be careful when you have subtraction that you still distribute it out, but you don't forget where that negative sign was. You could even have a negative number out here. And when you distribute this, you go negative 2 times 5, you're going to get negative 10. And then negative 2 times negative x, those two negatives are going to cancel to be a positive plus 2x. Or you could say this is the same as subtracting a negative 2x, but those end up being the same. One more example, negative 3 times x, and then negative 3 times negative 2 makes a positive 6, or it's subtracting the negative 6 that you got from negative 3 times 2, right? Subtracting a negative is the same as adding a positive. If you just see a negative sign out front, remember you have a little invisible 1 right there. So this is negative 1 times x is negative 1x. And negative 1 times negative 2 turns into our positive 2. Subtracting negative 2 is the same as adding 2.